This movie is about convolving. Convolving is the process of changing the value of a pixel according to the value of the pixels that surround it. Images can be made to be more clear or more fuzzy. This is done with a filter, and the filter itself is controlled by a matrix. So there are lots of different convolutions that can be applied to images. For this example, I define 6 different convolution matrices and put them in a program that loads an image and allows you to interactively apply each of the individual convolutions to that image. The Convolve-Op filter requires that the image input to it is a buffered image object, so the original image is loaded and stored in a buffered image in the constructor. This line constructs the buffered image object. It's the same size as the image itself, and it's of type RGB, so it can hold an image. A buffered image object is a subclass of an image object, so it can be used by the graphics object and painted directly to the screen. In fact, if you want, you can convert any image to a buffered image and edit the image directly by editing the raster, but that's another subject. In this program, we use the original image as the input necessary to create a new buffered image object named Normal. This is the one that we'll be putting through the Convolve-Op. Now, the default selection is to display the image normally. That is, we will be running it through the Convolve-Op filter, but because of this selection, it will use the identity transformation, and it will come out the same as it went in. No actual changes will be made by the filter. I'll show you this in a minute. Now, here is the use of a graphics 2D object that we haven't seen before. A buffered image object has a graphics 2D object inside it, and we can use that object to draw things into the buffered image. This can be handy for creating images in memory, and we're going to be doing that in a very simple way right now. All this code does is draw the image that came in as an argument into the memory of the buffered image. It's sort of like having a screen in memory and painting the image on it. Inside the paint method, we create another reference to a buffered image object. Of course, the paint method is called whenever the time comes to repaint the image on the screen, and we do that by first creating an image and storing it in the current buffered image object. Now, to create the new buffered image object, we're going to have to use the Convolve-Op filter, and the Convolve-Op filter is controlled by a kernel object. If you recall, the Convolve-Op filter modifies each pixel by including information from the pixels that surround it. This kernel constructor specifies the square of pixels that are to produce the output pixel, and that square is 3 by 3. Now, here's how that works. 9 pixels are used as the input, and a multiplier is applied to each one of the 9, and the result is then all added together to produce the final pixel. Take a look at the identity. There are 9 numbers. The square is 3 by 3. The first 3 is the top row. They're all 0. The second 3 is the middle row. The middle member of that row is taken at its full value because the matrix has 1 as its multiplier. The bottom row is all 0, so it doesn't come into play either. The result is that the pixel at the center of the square simply has its value duplicated in the resulting pixel. Nothing is changed. Now, in this example, all of the pixels are multiplied by a fraction of themselves and added to the resulting pixel. Because all of the values add up to 1, the resulting total brightness is the same, but every pixel takes on some of the color and some of the characteristics and whatnot of the pixels around it. The result is that the picture is softened by being blurred just a bit.